Hello class, and welcome to section 10.2, which is about the real number system. By the end of today's lesson, you will be able to identify numbers and classify them within the real system, as well as order these numbers and use some of these real number ideas to solve equations. So I just want to review a vocab word and then add a new term. We talked about irrational numbers back in the fall when we were talking about rational numbers, but remember, an irrational number is one that cannot be written as a fraction. The reason I bring that up is because square roots, which we learned about in the last lesson, are often irrational numbers. So in that last lesson, when we were talking about the square root of 33, and we were doing the estimate to find out what it was between, the actual answer for square root of 33 is a decimal that's going to go on forever. So it's an irrational number because that decimal isn't repeating or terminating, so it can't be turned into a fraction. So square roots are another type of irrational number. And then we have a new name for all types of numbers that we know of. We call those real numbers. Now, it might seem a little silly to call something a real number, but fun fact, once you get into high school, Algebra 2 and beyond, there are things that are called imaginary numbers, but don't worry about that. We're not going to get into that now. We're just going to stick to the real number system, which is all of the numbers that can be written in the fraction and all of the numbers that can't be written as a fraction, aka every single number that you could possibly think of. So, just a quick kind of refresher. We saw a chart similar to this when we were talking about the rational numbers, but I just want to, finalize this. So this whole big picture all together is the real numbers. Everything that is inside of this darker box we call the real numbers. Over here in this blue area, that would be where our irrational numbers live. So these are the numbers that cannot be written as fractions. So the square root of 33. Another example would be the square root of 2. You all know about pi being an irrational number. So these are the ones that live over here that don't have a repeating decimal. All of those are the irrational numbers. When we come over to here, this green box is the rational numbers. So these are all of the numbers that can be written as fractions. So for example, 1/2, or 0.3 repeating, because repeating decimals can be turned into fractions because that's 1/3. Or mixed numbers, you could have 2 and 4/5, or -7/8, or -6.93. So all of those fraction decimal numbers live out in that green area. A subcategory of the rational numbers are the integers. We talked about these in chapter 2. These are the positive and negative numbers that also includes 0. So 0, -2, -7, -24. Those all live out in the integer numbers. And in this very interior box, the most specific subgroup is the whole numbers. This is where all the positive numbers live. So all of these numbers that are positive are whole numbers, integers, and rational numbers because they live inside the pink box, which is inside the orange box, which is inside the green box. So if it's further in, it has more qualifications. If it lives more on the outer edges, then it only has one specific category. So if we're looking at classifying these real numbers, first we're looking to see if the number -2.5 is whole, integer, rational, or irrational. When we're looking at -2.5, it's not a whole number because it includes a decimal. It's not an integer because it includes a decimal. It is a rational number. And if it's rational, that means it automatically cannot be irrational. So a number cannot be rational and irrational at the same time. It can't be a decimal and not be a decimal or can't have an end and not have an end at the same time. On this one over here, 21 over 7, for some of these problems you need to reduce before you can solve. So 21 over 7 simplifies to 3. This simplified version is what we are now classifying. So this is a whole number. Because it's a whole number, it's also an integer. And because it's an integer, it is also a rational number. So this 27 over 7 hits 3 of the 4 categories. Go ahead and try these two on your own. 0.2 repeating is a rational number because it has that repeating, so it can be turned into the fraction 2/9. Over here, the square root of 38, it's not a perfect square, which means you're going to get a super long decimal, making it an irrational number. The next thing we're going to do is compare real numbers. When we do this, we want to decide if they are less than, greater than, or equal to each other. My suggestion is to turn all of these into decimals. So if you wanted to turn this into a decimal, we all know that 1/3 is 0.3 repeating. So I'm just going to say 0.33 for now. Usually rounding to the hundredths place will give us enough information, but you may have to go to the thousandth or 10,000th in some cases. Then I'm going to plug the square root of -15 into my calculator, and after I round, that gives me 3.87. Obviously the 3's are the same, but 33 is smaller than 87, which means that 3 1/3 is less than the square root of 15. So we use those decimal values to decide which is greater or smaller. Go ahead and try this one on your own. Plugging it into the calculator, you've got 7.54, and then this one is just 7.4, or if you include 2 decimal places, 7.40, which makes the square root of 57 greater. When you are arranging numbers when you are arranging these real numbers from least to greatest, again, we want to use that decimal. So starting with -8 4/5, you could 4 divided by 5 in the calculator, and that's going to give you -8.8, and then we can add that 0 so that it's 2 decimal places. When you type in the square root of 64 into the calculator, you're going to get an answer of 8, and then we put that negative out front. -8.3 repeating. I'm going to go ahead and expand that out to 2 decimal places, so 8.33. And then when I put the square root of -76 into the calculator, I'm going to get an answer of -8.76. Now, these are negatives, so the least is actually the greatest value. So we're looking at 80, we're looking at 0, 33, and 76. 80 being the biggest, which means my smallest value is -8 4/5. When you are putting them in order, you need to use the original values, not the rounded decimal values. So then your next one is going to be the negative square root of 76. When you're typing the square root into Edpuzzle, if you hold the Option key, which is in the bottom row of your computer, and it's the 3rd key in, if you hold the Option key and hit the letter V, it's going to give you this square root symbol. So again, Option key with the letter V gives you the square root symbol when you are typing that into Edpuzzle. So you've got the negative square root of 76, and then we're going to go ahead and continue looking for our next smallest one, or our next biggest one, excuse me, which is going to be -8.3 repeating. Unfortunately, you can't type the repeating symbol into Edpuzzle, so you're just going to have to type it in. If this was your answer, you would just say -8.3, and I would understand what you mean. And then the last part would be negative square root of 64. Again, if you're typing it into Edpuzzle to get that square root, it's the Option key and then the letter V. So this is my order from least to greatest of the real numbers that I was given. Go ahead and try this one on your own. So putting it in order from least to greatest, we've got 15 over 3, and then the square root of 30, and then 5.6, and then 5 2/3. The next thing we are going to talk about is solving equations. Again, I mentioned yesterday, square roots are going to be treated like an exponent. So the exponents are going to fall where they normally do in PEMDAS. If we look now when we're solving, we're looking at SAD-MEEP. So this adding and subtracting piece needs to be taken care of first. So I'm going to subtract 6 from both sides of my equation because the subtraction part comes first. And I'm going to get a squared is equal to 36. To undo squared, we need to take the square roots. So if I take the square root of both sides, I'm going to end up with a is equal to 6. Now, it doesn't specify whether we want the positive or negative answer. So our other option is to say a is equal to negative 6. 6 squared is 36, plus 6 is 42. Negative 6 squared is 36, plus 6 is also 42. So unless it specifies that it only wants the positive or only wants the negative answer, you should always be listing both of them. So in this case, your answer would be a equals 6 or a equals negative 6. Go ahead and try this one on your own. In this example, you should be dividing by 2 first and then taking the square root, which is going to give you n is equal to 9.22 or n is equal to negative 9.22. Last thing we're going to do is solve problems in the context of a word problem. So we have that a tsunami is caused by an earthquake on the ocean floor. The speed of a tsunami can be measured by the formula s squared over d is equal to 9.61. where s is the speed of the wave in meters per second, and d is the depth of the ocean in meters where the earthquake occurs. What is the speed of the tsunami if an earthquake occurs at a depth of 632 meters? So our job is to plug in our important information into our equation. So we're looking for the speed, so I'm going to leave that alone as s squared over our depth, which is going to be 632 meters, is equal to 9.61. Again, we're going to use SAD-MEEP, so I need to get rid of that divide by 632. So I'm going to multiply both sides by 632. And when I do that, that's going to give me that s squared is equal to 6,073.52. And now I'm going to take the square root of that answer, or the square root, of both sides. And I'm going to have that s is equal to 77 point, after rounding, 93 meters. Now, normally I said you would go on and look at the negative answer, but we can't have a negative amount of meters. So our answer is going to be a depth of 77.93 meters. Go ahead and try this one on your own. So we plug in what we know. We plug in for that area and our aspect ratio. So we've got 4.5 equals s squared over 50, multiplying both sides by 50, and then taking the square root, you get a wingspan of 15 feet. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.